Today, we're taking a journey up through this incredible, invisible shield, Earth's atmosphere. And look, for anyone preparing for competitive exams like the CSS or PMS, you know this topic is absolutely crucial. So let's build that rock-solid conceptual clarity you're gonna need. So let's start with a big question. What is the one thing, the only thing, standing between every living creature on this planet and the deadly, freezing, irradiated vacuum of space? It's this amazing, dynamic system all around us. Understanding its structure isn't just interesting, it's fundamental.
And that shield, of course, is the atmosphere. You can think of it as this huge gaseous blanket wrapped around our planet, stretching thousands of miles high. But it's so much more than just air. It is the most complex and critical life support system imaginable. And trust me, it's a favorite topic on your general science and ability papers for a reason.
Okay, so what are we actually breathing in right now? You'd probably guess it's mostly oxygen, right? Well, here's a classic exam MCQ trap. The air is actually about 78% nitrogen. That oxygen we need to live, that's only about 21%. And almost all of the rest is a gas called argon, with just a tiny sliver of other stuff.
Now, this is where it gets really interesting. See that tiny little fraction of other gases? Hiding in there are things like carbon dioxide and water vapor. And even though they're just trace amounts, they have a superpower. They are incredible at trapping heat. This creates the greenhouse effect, which is the only thing keeping our planet from being a frozen ice ball. You absolutely have to grasp this concept for any question on climate.
All right, you ready to start our climb? Our journey begins right where we are, in the layer we all call home. This is the densest, most active part of the atmosphere, the troposphere. And hey, quick memory aid for the layers we're about to cover, you're going to want to jot this down. Just remember the phrase, trust me in the exam. That's troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Simple.
So this is our world. The troposphere is where everything happens. It's the thickest, densest layer, and it holds nearly all of the atmosphere's water vapor. And what does that mean? It means this is where you find every cloud, every storm, every drop of rain, the powerful monsoon systems that are the lifeline for agriculture in Pakistan. That is the troposphere doing its thing. But here is its #1 rule. The higher you go, the colder it gets.
So why does it get so chilly as you go up? Examiners love to test this concept. It's because the troposphere is heated from the ground up. Think of the Earth's surface like a giant radiator. The sun's energy hits the ground warms up, and then it radiates that heat back into the air. So the farther you get from that radiator, say going from the beaches of Karachi up to the peaks of the Karakorums, the colder it gets. This steady drop in temperature has a name, the normal lapse rate.
But then something really weird happens. As we climb above the highest clouds, we cross this invisible boundary called the tropopause, and suddenly we enter a whole new world. Welcome to the calm, clear, and very different skies of the stratosphere.
The stratosphere is a totally different beast. It's incredibly stable and dry, which is why commercial jets love to cruise up here, above the weather. But wait a second, look at this. The temperature suddenly starts to increase the higher you go. It's a complete flip, a total reversal of what we just saw. This is a classic conceptual trap for students. So, what in the world is going on?
Well, the secret ingredient here is a special molecule, ozone. The ozone layer is basically Earth's natural, heavy-duty sunscreen. It absorbs almost all of the sun's dangerous ultraviolet radiation, and as it soaks up all that high-energy radiation, it gets hot and it heats up the air around it. That's what creates that bizarre temperature inversion. This protective function is so critical, its depletion led to the famous Montreal Protocol, which is a perfect example for any essay on environmental governance.
Okay, let's keep going higher. We're now entering the middle sphere, the mesosphere, and this layer has a really cool job. It's our planet's frontline defense against invaders from space.
The air up here is ridiculously thin, but it's just thick enough to create friction for all those little space rocks flying towards us. That friction makes them burn up, creating those beautiful streaks of light we call shooting stars. And look at that, the temperature has flipped back again. It's getting colder as we go up, and I mean really cold. It can plunge to -90 degrees Celsius, just mind-numbingly cold.
So why the deep freeze? Well, it's actually pretty simple. There's no ozone layer up here to act like a heater. The air is so thin that any little bit of warmth it might have just radiates away into the vacuum of space way faster than it can be replaced. This is, hands down, the coldest place in our entire atmosphere.
Our journey now takes us into the vast, almost ghostly upper reaches of our atmosphere. This is a place of incredible energy, spectacular light shows, and a really strange paradox. We've arrived at the thermosphere.
Whoa, just look at that number. Temperatures in the thermosphere can rocket up to over 1,000 degrees Celsius. That's hotter than many industrial furnaces. How on earth is that possible, so close to the absolute zero of outer space? Well, this is where we feel the raw, unfiltered power of the sun. Up here, the very first molecules of oxygen and nitrogen get absolutely blasted by the sun's most intense, high-energy radiation. We're talking X-rays and extreme UV. This constant bombardment supercharges them with energy, and that's what we measure as this incredibly high temperature.
But here's the mind-bending paradox. Even with those scorching temperatures, if you could somehow stick your hand out into the thermosphere, it would feel unbelievably, dangerously cold. How does that make any sense? This is a higher-level concept, so let's break it down.
It all comes down to density. Imagine you're in a giant empty warehouse, and in that warehouse, there's one single tiny speck of dust that's red hot. That speck has a really high temperature, right? But is the room hot? No way. That's the thermosphere. The individual molecules are super hot, but they are so incredibly far apart that they just can't transfer that heat to you. It's a perfect example of high temperature, but very low thermal energy.
And that brings us to the very top of our world. This is the Exosphere. It's the thin, fading outermost edge of our atmosphere, where Earth's breath finally, slowly gives way to the silent expanse of space.
This is basically the point of no return. The air here is so incredibly thin, and gravity's pull is so weak that individual atoms of gas can actually just break free and drift off into the cosmos forever. This, right here, is truly the edge of our world.
So there you have it. We've journeyed from the stormy troposphere all the way to the edge of space, through layers of freezing cold and blistering heat. But what does it all mean when you put it together? Let's zoom out now and look at the big picture, because this is why this incredible system is so vital.
See, what we have is one single, brilliantly connected system. It's our protective barrier, shielding us from deadly radiation thanks to that ozone layer in the stratosphere. It's our planet's thermostat, thanks to those greenhouse gases in the troposphere. It is, quite literally, the air we breathe. And it's the engine that drives the water cycle, creating the clouds and rain that sustain all life. Every single layer we visited has an absolutely indispensable role to play.
And that really just says it all, doesn't it? Our atmosphere isn't just some scientific curiosity. It is the thin, fragile, and completely irreplaceable shield that separates our beautiful living world from the cold, silent emptiness of space.
And so we end on this thought. Every breath you take, every cloud you see, every bit of warmth you feel, it's all a gift from this delicate, complex system. The final and most important question, especially for you as an informed citizen and maybe even a future public servant, is this. What is our role in protecting this shield, for ourselves and for all the generations that will come after us?